Last week was the second workshop in this 7-part series on supervised machine learning in Python with Scikit-learn. Remember, our business goal is to predict wine quality on a 1 to 10 scale using historic data from 1,500 bottles, which includes an average score from wine experts, the wine color, and several production process values. This time, our focus was on feature engineering and pipeline building, where we added the package feature engine to our existing helper libraries, as well as several new Scikit-learn methods. Here's a quick recap. We start with the dataset. The histograms show us that most numeric variables are on different scales. Some have very small ranges, and not all are normally distributed. Feature engineering involves changing actual values or adjusting the structure of the original dataset to optimize it for use in a machine learning algorithm. Recall that we split our full dataset into a training set from which we will build the model and a test set from which we will evaluate its performance using train-test split. It can be helpful to separate our numeric and our categorical input variables, which we do quickly using the select dtypes function. We first explored for outliers on the numeric variables using a simple approach. If the absolute value of a given numeric value is greater than 3 standard deviations away from the mean, we label it an outlier and replace its value with that of the cutoff value. This is especially important if you have so many variables that you can't explore outliers individually, and you just want to reduce your risk that some extreme outliers will unduly impact your final model. Then we looked at scaling. Generally, you want to scale number variables so that they have similar ranges. If we don't, these different scales could bias our results by placing too much significance on larger values. We could use standardized scores by subtracting the mean from each observation and dividing it by the standard deviation. The new range will be -4 to 4 in most cases, and in Scikit-learn, this is the standard scalar method. We could also use the min-max approach, where we subtract the series min from each observation and then divide by the range of the series. In Scikit-learn, this is the min-max scalar. Scalars change the underlying range of numeric variables, but don't control for skewness. For that, we turn to the Yao-Johnson transformer. It does a pretty good job, as you can see, for several of our variables. Machine learning models love numbers, but sometimes we want to use the categorical variables in our predictions. To do that, we can use one-hot encoding or dummy variables to convert string values like red or white wine from our wine type variable. In several models, it makes sense to drop one of the subsequent columns, as keeping all of the columns is redundant and can have negative consequences. With linear regression in particular, we need to consider correlations across the feature variables too. Having this multicollinearity can result in strange model results. Thankfully, we can quickly use the drop correlated features function to drop some of the variables that have such relationships. In our case, when correlation among the input variables was greater than 0.6. Finally, we build feature engineering pipelines that allow us to stack all of the previous adjustments into a pipeline that we can apply to our training and test datasets. In Workshop 3, we'll add model initiation and fit to this pipeline. Before you join us for that, watch the full recording from Workshops 1 and 2 and download all of the data and all of the code from those events from the links below.